Okay, so this is our second little matrix show. I want to just go over what occurred today in regards to our matrix A. Okay, we had our 3, 2, 7, 5, 4, 1, 0, 10, 0. Now, what we needed to do when we were talking about the calories for each of those items, what we needed to be doing was, in fact, writing the calories in this way: 690, 490, and 420. Okay, because what we do when we multiply matrices is we take this one here and we multiply it by this one here. Okay, we take this one here and we multiply it by that one there, and we take this one here and we multiply it by that one there. Okay, in terms of the resultant matrix that we achieved today, okay, it's definitely still exactly the same. Okay, however, when I wrote out the calories matrix, I wrote it as a 1 by 3 matrix, and that was wrong. Bad, Mrs. Thompson. Okay, it should have been written like this, which is a 3 by 1 matrix. Okay, so if we look over what we've got there, the resultant matrix, if I was to call that one B, for example, all right, so A times by B, all right, or in fact the way in which it is written is A, B. The resultant matrix is, and this is the way in which we would write it, AB equals 2070, 980, 2940, 3450, 1960, 420, 0, 4900, and 0. Okay, so that is AB, all right, and that gives us that distinct information as we were talking about previously, where we have got Isabella's pasty calorie intake being 3 times the pasty calories. Okay, so although we have got pasties here, muffins here, and muesli bars here, when we put them into the calorie intake, the calorie matrix, pasties goes on the top, muffins goes the second line, and muesli bars goes here. Okay, so when we go across in matrix A, we go up and down in matrix B. Okay, when we are putting our data into the matrices. Okay, that should make sense. Okay, I'm going to go through an example that is in the textbook. So I'm going to look at Lisa, who goes shopping at a store to buy 2 loaves of bread at $2.65 each, 3 litres of milk at $1.55 per litre, and 1 500-gram tub of butter at $2.36. So what we want to do is look at those pieces of information and create a row matrix. Okay, so a row matrix. So Lisa has gone to the shop, and what we're doing is we are putting the quantities into a row matrix. We have got, we'll call the matrix Q for quantities. Q equals 2 for the 2 loaves of bread. We will put 3 in there for 3 litres of milk, and we're going to buy 1 500-gram tub of butter. Okay, so that was 2 bread. We have got 3 litres of milk and 1 butter. Alright, that is what is represented there in this, which is called a row matrix because it is just a row. Okay. Then we are going to put the costs into a cost matrix. Okay, we'll just make that like that. We're going to call this matrix A. Okay, and our cost matrix has got $2.65, $2.65, $1.55 for our milk, and $2.35 for our tub of butter. Okay, now just remember, as I said before, at the top here we've got our bread, which relates to the first item there. Second one down relates to the second one across. Okay, and the third one down relates to the last one there. Okay, now if Lisa goes to another shop, all right, and the prices are different, okay, we are going to create a cost matrix, a single cost matrix that describes different costs, okay, but that still relate to our bread and our milk and our butter. Okay, so if I create a cost matrix that represents shop A and prices in shop B, this is what it is going to look like. All right, we are going to have well, let's just say that our cost matrix for shop B is $2.25 for bread, $1.50 for milk, and $2.20 for butter. If I combine those two pieces of information, I can actually put it all into a single matrix, okay, and we will call that matrix, that's not going to work, it's going to really make it quite confusing. Let me just call our cost matrix that includes everything. It's going to be $2.65, $1.55, and $2.35. And then in the second column, it's going to be $2.25, $1.50, and $2.20. All right, so that is our cost matrix, and that is called cost matrix C. All right, so we've got A here and B here, and we've got bread and milk and butter here. Okay, that's hopefully very straightforward. If I then write that out for you on a different slide, we have got that Q equals 2, 3, 1, and that C equals 265, 155, 235, and 225, 150, and 220. So that's bread, milk, butter, and that is store A, and that is store B. Okay, so that is a single cost matrix for that data. If I want to represent the total cost for the bread, the milk, and the butter, what I do is I multiply Q by C. All right? And the way that I do that is I take the 2 loaves of bread here and I multiply that by 265, and then I add that on to the cost of 3 litres of milk multiplied by 155, and I multiply, and then I add on to that 1 tub of margarine by 235. Okay, so what I would do is I go 2 times 265 is equal to, 530 plus 3 times 155 is equal to 4.65, and 1 times 2.35 is equal to 2.35. Okay, so that is a total of 1230. Okay, so we put that actually into the matrix 1230, and then what we do to find how this relates to shop B is we go 2 times 225, which is $4.50. We add that on to 3 times $1.50, which is also $4.50. Whoops. And then we have got 1 times $2.20. Alright, and that comes to the grand total of $11.20. So this matrix, which is Q times C, is a 1 row times 2 column matrix, and what it shows is the total cost for those items in shop A and the total cost for those items in shop B. Alright, this is actually reasonably advanced stuff, so we took a big jump today, and hopefully it has got you thinking and it hasn't wigged you out too much.